So I joke when you drop that because I sit there all the time and I do this, and people keep going, "Do you ever drop it?" I said, "Yeah, I've counted. This year I've dropped. Last year I dropped 5 times total." So it's just like you drop. Like, no. Sorry, I didn't mean to do that. Angle pair. When we did angle pair stuff in chapter 3, we first started talking about it in relation to the things that we did back in chapter 1. In chapter 1, we did a couple of definitions as far as some of them were concerned. One of the first ones was adjacent angles. One of the first definitions we talked about in chapter 1 was defining what were called adjacent angles. Do you vaguely remember what adjacent angles were? Two angles next to each other, what do they have in common? Vertex and a side. Yeah. They could be angle bisectors or adjacent ones. Yes, they're bisects on that. So adjacent angles, just for a real basic idea. Angles with common vertex and side. They don't necessarily have to be congruent. They can be. They don't need to be. They will be when we talk about angle bisectors. Then there are adjacent angles that are congruent. After we talk about adjacent angles, one of the next things that we defined was a thing called linear pairs. And really, if you get into it, a linear pair is an adjacent angle, correct? But it specifically creates a what? Line, 180. Okay. And the reason why I wanted to refresh these things is because we used adjacent angles. We used linear pairs as we got into our 2 parallel lines cut by a transversal. So remember, a linear pair was 2 adjacent angles that create a line. Yep. They add up to 180 degrees. There's supplementary to them. Okay? Adjacent angles that are supplementary are called linear pairs. So we had to use this term called adjacent to be able to define the term that was called linear pair. And we also had another angle pair that didn't quite look like these, but we used them a lot in 3. And when I say 3, I mean in chapter 3. What was it? Vertical, very good. And that was vertical angles. And if you recall, when we dealt with vertical angles, that was just basically when you had 2 lines that intersected. When 2 lines intersected, you had 4 angles that were created. Of those 4 angles, at most 2 of them were, you had 2 of them that were the same. If they were perpendicular to one another, all would be 90. But what we did was we defined them as the angles that were opposite one another with that common vertex. The sides created lines. We knew that those 2 angles were the same. Therefore, the other pair of them were also the same. And the reason why we wanted to show this was because as we got into 3 with all the other angle pair relationships corresponding, alternate interior, those guys, when we first drew that out, when we had what we said 2 parallel lines cut by a transversal. Remember how we first marked up our diagram? We picked one spot. When we picked that one spot, we then said, where's its vertical? Where's its alternate interior? Where's its vertical? And then we use those ideas of vertical angles, alternate interior, linear pairs to decide whether or not angles were the same or angles created lines. We knew that if the lines were parallel, If the angles matched with tick marks, they were always congruent. If they matched with both of them not having tick marks, they were congruent. And then if they had one with and one without, they were always added up to equal how much? 180, because they created a line. They created a linear pair. Okay? But in order to do all that, we had to remember what were the four types of angles. And now, I know a lot of you guys yesterday kind of got ahead on the angle sheets, and that's great. It's fine. No problem with it. Put it away. Stop looking at your phone. Right, so put it in your pocket. Don't worry about it. A lot of times what people were doing, you guys did fine. And as I was walking around yesterday and helping people out earlier today, most of you guys know how to set up and soften the angles without a big deal. Aside from a silly mistake here or there of mixing up something. But for the most part, you understand it. But what we're trying to help you guys do today, it wasn't in the instructions, we want to make sure we label what angle pair you're working with whenever you're working with them. Because that's the vocabulary that you have to understand. Okay. So going back to the angle pairs, those four types that we had, one of them was alternate interior, which meant we had alternate exterior. Then we had corresponding. And lastly was, we called them consecutive interior. So we had four of them. Okay. So with those four, what we always wanted to be able to do was identify what they looked like in a diagram, and then say what they were in terms of words. Okay. And I know we've done this a few times, so it shouldn't be all that difficult, but just as a refresher, if two parallel lines are cut by a transversal, alternate interior angles. Well, alternate means they switch sides of the transversal. Interior means they are on the inside of the line. So we called them inside, opposite side. They were these two guys, or those two. We said inside the lines, opposite side of the transversal. Okay. And that's how we wrote this. Over and over and over. We took out all the crazy vocab words to it and made it very user-friendly. Because you should. Okay. What's the difference between alternate interior and alternate exterior? It's on the outside, very good. Hence the word exterior. Right? Did you need a pencil to ask for again today? Okay, just making sure. All right. So again, if I'm looking at the outside ones, they're outside the lines on opposite sides. Okay? I can say here and here. Obviously, there's another step. I'm just marking one of them just for visual sake. And we wrote it out. Outside the lines, on opposite side of the transversal. Okay. Now, when the lines were parallel, what did we know about those two sets of angles? Were they the same or were they supplementary? If you had alternate interior angles when the lines were parallel, are those two angles the same or are those two angles supplementary? They're the same. They're congruent. So we know that if two parallel lines were cut by a transversal, these guys were congruent. Same thing with the exteriors. Those guys were congruent. Congruent, same measure, same value. As you get into the corresponding and consecutives, corresponding angles looked a little different. Where were corresponding angles located? What do you mean? So if we say top right, where is it on the next one? Top what? Top. If I'm top right on first, yeah, they'll be on the top right of the other one. So if I say corresponding, if I'm looking at top right here, it has to be in the same spot, same position on the other one. It'd be top right there. Corresponding angles are in the same spot, same position. Same spot, same position. How many corresponding angles are there when you have two parallel lines cut by a transversal? Could they be the same angle? How? What would the angle have to measure if they're all the same? They'd have to be perpendicular. The line was perpendicular to both of them. All 8 of the angles wind up being equally 90 degrees. Okay. So again, corresponding angles are also congruent because those guys will always match up with tick marks. What's that? And then the last one was the consecutive interior. Consecutive interior where were those? Same side inside. Very good. So consecutive interior were same side inside. It was this guy and then that one. They add to 180 degrees. The reason why those two guys are going to add up to 180 is because they don't match with the tick marks. If you go through and you look at two parallel lines cut by a transversal, and you guys mark up all your diagram, vertical, alternate interior, vertical. The two on the inside on the same side never have the same tick mark, unless they're 90, obviously. But all the other possibilities is what this occurs. Now, using the idea here, if this was 40 degrees, that makes this one 40 degrees, that makes this one 40 degrees, and this one 40 degrees. Oops, 40 degrees. Getting ahead of myself. What? 50? You're thinking complementary, you're thinking right angles. That's not the right thing to do. Now, the reason why this works is because these two guys have to be supplementary, because since these two guys are corresponding, they create a line. So since they match up against ones that are making linear pair or create linear pairs, that's why they might be supplementary. Sorry, bad humor. Okay. Now, as you're going through the stuff on that sheet then, for example, if I'm looking at these first few, if I look at number, nope. If I look at number 3, the instructions for the first handful were find the value of x that makes the lines parallel. Now, most of you guys knew that you had to figure out whether they were congruent or supplementary. But what the instructions didn't say, it didn't say, hey, what was the angle pair that was going on? I would like you to, and the reason being is that it'll help you tomorrow in case I ask you, what's the angle pair relationship between these before you do the work? You know what I mean? So I could easily add a statement to this. Find the value of x that makes those lines parallel, then state the angle pair relationship, which means, are they a linear pair? Are they vertical angles? Well, actually, those won't help with parallel. But if they're being parallel, that would have to be alternate interior, alternate exterior, corresponding or consecutive interior. Those will be the 4 that help you show that things are parallel. So here, what most of you guys have done is you just follow your tick marks. Did they match? Yeah. They matched up, which means they have to be equal. So you'd set them equal. 5x plus 5, 45. What's the angle pair? Outside, opposite sides. Outside. Alternate exterior angles. super quick math here. Subtract 5, divide by 5, and you get x is subtract 5. Okay. And that's good. I'm asking that, or I should say, we're asking that you guys just take it. I know most of you guys probably already did that, the math part, but it's a good study skill to be able to relabel what exactly you did, okay, by identifying them. That's how you set up those. If you look at the bottom of the page then said, hey, find the value of, find the angle that's bold, okay? When you look at the page, you should be able to tell which angle is bold because it's emboldened, or bolded, whatever. You know that the lines are parallel because it tells you. What's the angle pair relationship between those two? They're corresponding. I know that they're parallel, so corresponding angles are congruent. So all I have to do now is the math of 67x plus 1 is 66x plus 3. Whew! Pace yourself on that two-step equation, ladies and gentlemen. Please pace yourself. I know, but I have faith in you. It's little, but I have faith. Hey, you'll miss all the undercuts and the jokes when she takes over. Then that'd be good. And she will, guys. Don't worry. It's all going to be fun. So you get a value of x is equal to 2, but remember the question asks you, find the value of the angle that's bold. So what do you do with that 2? Substitute back in. So 67 times 2, I believe, is 134. Yes. Add 1 to it, and you get. That's the idea behind these. Also, it's not a bad idea to double check it with the one that it was matching up to. They should equal the same amount. As we get going through these things, this is what we're hoping you guys to be able to do. I know it didn't say to do that, so if you've already gotten that far, that's great. Go for it and just rewrite them down. It's just a good study thing. Continue working on these, writing out what they're looking at. Go from there. We'll meander about and help you with any questions that you might have. Some students have been asking about what do I do for extra graphing? On that page 194 in the textbook, there are other equations that you could graph if you wanted to go back and do some of those. I just realized I left all the graph paper around the copier, so we'll run it and grab that real fast and go from there. But other than that, that's kind of what we're doing, guys. On Friday, we'll start chapter 2 with some very, very simple definitions. So it's very light going into the weekend because I know you won't do anything because it's homecoming. So that's besides the point. I know, that's why it's very light. So questions in particular that you've gotten to so far for the good of everybody before you start meandering on your own. Oh, real quick, I know yesterday Flex and you guys were in here. I had 24 kids. That's a little bit too much. So I'm gonna have to start cutting back on the amount of people that come in. I'm gonna try and keep it to like 3 or 4 kids per class max. That way it's able to get their way. Yesterday I did not get their way. It wasn't fair. So you have to start remembering that if you do have a question on something, you know for a certain, it's just one of those quick things. Swing by in the morning. We're here in the morning. I got the music. It's loud. You'll hear it. Just wander by. You'd be better. A lot of times you're better off just asking then as opposed to during Flex. Not to say that Flex is still not an option. If you still want to try and come in, please do. Still sign out. But remember, I'm going to have to try and restrict it out to a few, 3 or 4 kids per class rate because 24 is a little bit much for one person. Okay. All right. What? What's that? What's that? Oh. Outside tomorrow. Do you want to grab those? I left them on the copier.